All right, so today what we're going to do, this video is going to help people who need to add fractions that have a different denominator. Adding fractions of the same denominator is extremely easy. You add the tops, the top of the fraction, the numerator. It's very simple. The problem is, what's the problem with adding 1/2 and 1/3? Well, let's talk about that. I want you to picture in one hand I have a nickel, the money. I have a coin, the nickel, one coin of the nickel. And in the other hand, I have one coin of a quarter. So I have a quarter and a nickel. See, the problem is that some people might take those. If you didn't know anything about money, you might take both of those and put them in one hand together and say, yay, how much money do I have? I have 2 because I had 1 and 1. The problem with that is that quarters and nickels are not worth the same amount. Even though there is only 1 quarter and there's only 1 nickel, they are not equal. What we could do, though, and we're going to do this with fractions too, is we could convert the nickel into pennies. We could convert the quarter into pennies. Then, since we converted them and they're both pennies, then we can add the quarter and the nickel together. We'd have 5 cents plus 25 cents, and that's 30 cents. The same idea applies to fractions. All you really have to do with fractions is to change your fractions into and convert them so that they have the same denominator. Unfortunately, it's not as easy as just writing the same number on the bottom. We have to have rules. There's rules for how we have to convert them. For this video, I'm going to be showing you using a 3D design program called SketchUp. I'm going to show you visual representations of a pizza that's made from these fractions that are added together. And then I'm going to show the exact same thing, how you would do them on this representation, which is, for most people, would be pencil and paper. I'm going to be typing it in, but most people would be pencil and paper. Okay, so let's get started. Before we start, we have 1/2 and 1/3. Let's take a look at what that looks like on our program SketchUp. So I'm going to zoom in a little bit. You can see a line. That's going to be the radius of the circle. And watch what happens. I'm building a circle. I've made it, cut it in half, and I'm labeling it. And there's 1/2 plus 1/3. I'm even going to color them different, make them different colors. Now I've done all this in advance, and I'm just actually redoing the steps I did before. So it's going to go very quickly. Now watch what happens. You see now, again, just like the nickel and the quarter, you can't say they're both 1 and just put them together and get 2. If you look at this, what you really have to do here is you can't add 1/2 and you can't add 1/3 because they are different sizes of pizza. So they're not the same. You can't just say they're 2 slices of pizza and put them together and say, oh, it's 2. Because is it 2 halves? No. Is it 2/3? No. We have to change them to sixths. Why is it 6? Here's why. Listen as I make these lists of numbers. Here's my 2s. 2, 4, 6, 8, 10, 12. Listen to me as I make my list for the 3s. 3, 6, 9, 12, 15. Oh, wait a minute. Did you notice that 12 was on both of those lists? It was, and that would work. I'm going to use the easier one. Did you also notice that 6 was on both the lists? So watch what happens. I'm going to split this up into sixths. Now you can see the pizza is clearly split up, I'm going to zoom in a bit, into 6 slices. So, and it's kind of a 3D drawing, so we could kind of rotate it however we wish. I don't really like that upside down, so I'm just going to put it back over here. Okay, now what happens? This is not 1/2 and 1/3 anymore, is it? 1/2 has been cut up into 3/6. And the 1/3 is now 2/6. Hey, wait a minute. Remember I said it's okay to add pennies and pennies together with money because they're actually worth the same amount. Pennies and pennies are the same. Sixths and sixths are the same also. Since I have 3 here and 2 here, it's equal to 5/6, isn't it? Okay? Let's show this one. Now go back. This is where you're going to want to pick up the pencil and paper. And let's go ahead and do this. What was the number I used for the denominators? It was 6. So I'm just going to go ahead and put that right up at the top. You can see that I put a 6 here for this problem. And I'm going to do that again. If that's 6, then these both have to be sixths. Now, what do I have to multiply 2 by? In this problem here, 2 times what? 3. That's right. And if I do that on the bottom, I have to do 3 on the top. And then I'm going to get 1 times 3 is 3. So the numerator is 3, the denominator is 6. Remember our drawing? There it is, 3/6 right there. So we can see that clear. Let's go back here and let's keep going on this problem. The bottom, 3 times 2 is 6. There's the 2. Since I have to do the same thing to the numerator and denominator, I'm going to go ahead and do that on the top of the fraction. 1 times 2 is 2. So there we have 2 6. And look at this. Remember earlier in the drawing, we had 2 6 and we got 5 6 for the answer. And watch what happens here. If we add the numerators, 3 and 2, we get 5 6. Again, I cannot stress it enough. It's important to remember that you can never add fractions together unless they have the same denominator. Because you know what? If they have different denominators, the size of those slices of the pizza are completely different, and it's just not fair to count them all together. You don't do that. Just like you don't say, I have $1, $1, and I have 1 peso, and if I put those together, I get 2. No. We know that dollars and pesos are worth different amounts. Now, if you converted the dollar into pesos, then you'd have pesos and pesos. You could add them together. Just like we converted thirds and halves into sixths. So they were the same, and we can just add them together. Let's do another one. We're going to pick up the pace. If that one took a while, it's because it was the first one. Let's pick up the pace. So I go back over here. Now this next problem is going to be 1/3 plus 1/4, isn't it? So what we have to do here is we have to come up with a number that works for both. Let's listen to the list. See if you can get it. 3, 6, 9, 12, 15, 18. The other list for 4s. 4, 8, 12, 16, 20. What did you hear on both?
12.
12, that's right. So for this one, Woodchick's going to use 12 for all the fractions, and actually the answer is going to be out of 12s. I mean, unless we have to reduce it, but we don't on this one. Okay? If you haven't had those, why don't you write those in right now? Okay? So all we've done so far is decided that we're going to change this using 12ths. Now I'm going to go and switch to the other one, and we're going to zoom out, and I'm going to slide over, and I have this one ready to go right here, I hope. There it is. I'm building it 1/3 plus 1/4. Let's go ahead and zoom into that. Okay, 1/3 plus 1/4 looks something like this using SketchUp. We've decided that 12 would be a good number to use, so I am going to break this down into 12ths. The good news is now all slices are the same size, but what happened to 1/3? 4/12, isn't it? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now let's go to the next one. And I hear someone saying it. It is 3/12. Okay, guys, 4/12 and 3/12. They're all the same. How many 12ths do we have altogether?
7/12.
Yeah, 7/12. And let's go back and finish that one on pencil and paper. That's why I really enjoy this SketchUp program. Okay, stay with me. Okay, 3 times what is 12? 4. So we have to do the same. And on 4 times 3 is 12. See where I put those?
Yeah.
I did it a little bit out different order than the last one. That's okay. But I have to go back. If I multiply by 4 down here, I got to do the same thing on the top here. And look what I get. And then the same thing. Oh, sorry. 1 times 3 is also... See, oh, whoops. So we get 4/12 and 3/12. Hey guys, if you look back at this, drawing, look at this. 3, 4, 4/12 plus 1, 2, 3/12 is 7/12. And we see the exact same thing in our problem. The answer is 7/12. So essentially what we're doing is we're just changing this so they have the same number on the bottom. We can add them together because they have a common denominator, same number on the bottom, right? And we can add them together and get 7/12. Okay, the last problem. Be careful on this one. Okay, listen to my list carefully. We got halves and eighths. We know that halves, now let's take a look at this first of all. This is how ridiculous it would be if you just went, oh, 3 plus 1. You can't do that. And let me show you why, real quick before we get going. There it is. Okay, so there's the problem we're doing, isn't it? Now do you see why you can't just go, hey, 3 slices plus 1 slice. Okay, cool, I got 4 slices. Okay, they're not the same thing. You can't just throw them all together like that and pretend that they are the same thing. They're not. Look at how massive the half is. I mean, come on. Anybody who chose pizza, if they had 1 slice, they would probably take the half, right? It's huge. So let's break this thing down. Now think about it. Listen to my list for halves, or for 2s. 2, 4, 6, 8, 10, 12, 14, 16, etc., right? Let's do our list for 8s. And I don't have to go very far on this one. 8, 16, oh, wait a minute. 8 was the first one, right? 2, 4, 6, 8. and 8 is where our list started. We're actually going to use 8ths for this. The good news is I don't have to change the 3/8, do I? I do have to change these. Now look what I've done here. Let me zoom in. I have now changed these into quarters. 3, 4, and you'll see that becomes 4/8, doesn't it? Or excuse me, I didn't say into quarters. I meant to say into 8ths. My fault. And then we're going to go to the next part, and look, now that since all the slices are equal, we just count them. 1, 2, 3, 4, 5, 6, 7, 8, or 3 plus 4 gives me 7/8. Let's move that over a bit to 7/8. Okay, let's finish up this assignment by doing this problem in our text. So we go back over here, and we figured out our LCD, the least common denominator, was 8. Hey, by the way, I'm going to tell you something. Brian just talked about 16ths. Would he have been wrong? No. He would have just had to reduce his answer when he gets done. 16ths would work, but it's not the least common denominator. The easiest one to use would be 8. So you know what? If you get 16, that would work too. But for this, we're going to use 8ths all the way to the end of our answer. Check it out. And then we're going to go, okay, 8 times 1 is 8. 3 times 1 is 3. Look at the top here. Those are just filling on in, aren't they? 2 times 4. Whoops. 1 times 4 is 4. Hey, look at here it is. 3 plus 4 gives us a numerator of 7/8. All right. In conclusion, the most important thing you can remember about fractions that most students mess up on when they're new at it, the biggest mistake I see over and over again in years of teaching is always that people go right away and they see 3/8 and 1/2. They want to add the 3 and the 1. But hopefully I've taught you that actually you can't add those pieces together because they're quite different. What you have to do is break it down so that they're all in the same denominator, meaning the same size of pieces of pizza. And then you can easily add them together using the methods that we just talked about. Thank you.